Hello, my name is Uğur Altun and I am a computer science student at Bilkent University. I am at my second year. Today I will present you my Physics 102 final project. I did an experiment. My experiment's title is Inspection of Kirchhoff's Circuit Laws. So let's first talk about the objective of my experiment. The purpose of my experiment is to observe and prove Kirchhoff's circuit laws in complex circuits by measuring the current and potential difference across given complex circuits and check whether the Kirchhoff's circuit laws apply, which are the sum of the currents into any junction equals 0 and the sum of potential differences around any loop equals 0. So let me give you the brief summary of my experiment. Before starting the experiment, the electric circuit given above is built with DC power supply, 5 resistors and cables. After setting the circuit above correctly, the first part of the experiment can be executed. In the first part of the experiment, the first statement of the Kirchhoff's law, which is called Kirchhoff's junction rule, is tested. To recall the rule, Kirchhoff's junction rule follows that the sum of the currents into any junction in the circuit equals 0. Therefore, the current that flows in each resistor will be measured and recorded in a table for different values of voltage. Furthermore, the current values in relevant parts of the circuit, for example, the current values between A, B and AC, will be added and compared with the measured total current in the system. Finally, voltage experimental total current graph will be derived from the data obtained from the branches of the electrical circuit. Then in the second part of the experiment, potential differences of resistors in the given closed loops in the figure, loop 1 and loop 2, will be measured and compared with the actual value of potential difference to test the second statement of Kirchhoff's circuit laws, Kirchhoff's loop rule, which states that the sum of the potential differences around any loop equals 0. Therefore, the sum of the potential differences of resistors in given loops must be equal to the potential difference between terminals. So to talk about the theoretical background of this experiment, we will use 3 important laws in the electricity of physics. The first is Ohm's law, which can be stated algebraically as like this. Then we will use Kirchhoff's circuit laws. To talk about these laws, the first is Kirchhoff's junction rule, which states that the sum of the currents into any junction equals 0, and which can be stated algebraically as this, like this. And Kirchhoff's loop rule, which states that the sum of the potential differences around any loop equals 0, and this can be stated algebraically as like this. In the experiment, we will verify the statements of the Kirchhoff's circuit laws by measuring the potential differences and currents in the significant points of the direct current electrical circuit. In the end of the first part of the experiment, we will add the currents we have obtained in relevant parts of the circuit and verify there is no accumulation of current in any junction by deriving a voltage current linear graph whose slope is equal to 1 over the equivalent resistance, and this can be stated algebraically as like this. And also I would like to add that we will use DC power supply, multimeter, cable sets and resistors as equipments of our experiment. To talk about the results of this experiment, in the first part of the experiment we have measured the electrical current flowing through each resistor, and we have added the currents flowing in each junction to verify that there is no accumulation in these junctions. Furthermore, we have derived the voltage current graph from the experimental total current we have found from relevant junctions and compared the value 1 over its slope with the theoretical value of equivalent resistance of the circuit. When we have compared these values, we have found an error percentage of 2.61%. Furthermore, in the second part of the experiment, we have measured the potential difference between the ends of each resistor and added relevant potential differences to verify Kirchhoff's voltage law. We have measured the error percentage for each voltage we have done experiment with, and we have found error percentages 1.7%, 2.3%, 2.8%, 1.6% for voltage values 10 volts, 15 volts, 20 volts, 25 volts, and 30 volts respectively. The error percentages may be caused due to loose contact between the connection points of the multimeter, the electrical circuit, power supply, and cables, which can lead to inaccurate measurements and miscalculations. Furthermore, the calibration of power supply and multimeter might have been inaccurate and resulted in miscalculations in the graphs and tables. Finally, personal errors such as making mathematical errors while driving the graph or doing operations with data might have contributed to the error percentages given above. All in all, in this experiment we have concluded that Kirchhoff's circuit laws hold for electrical circuits. There is no current accumulations in the junction parts of the circuit, and the sum of the potential differences at any loop in the circuit equals 0. Thank you for watching and have a great day or evening.